Welcome to all. COVID-19 has resulted in schools shut all over the world last year. As a result, education has moved online classes. In our YouTube channel, we are focusing the reading the English textbooks in Tamil Nadu matriculation syllabus so that students can review the subjects when they find time. We are recommending our kids and teens should learn the education from their teachers, and in-person education is extremely good for all age students since teachers know students' needs. Students, today we are going to read 10th Standard Science Book, Unit 3 Thermal Physics, page number 32 to 34 about Introduction, Temperature, Absolute Scale, Kelvin Scale, of Temperature, Thermal Equilibrium. In 3.2 Thermal Energy. What is thermal energy? Characteristic features of heat energy transfer. Other units of heat energy. Thank you. Learning objectives. At the end of this lesson, students will be able to understand the concept of heat and temperature. Know the absolute scale of temperature. Understand the thermal energy and the thermal equilibrium. Classification of expansion of substances. Know the fundamental laws of gases. Distinguish between real gas and ideal gas. Derive the ideal gas equation. Solve the numerical problems. Introduction. Sun is the primary source of thermal energy for all living organisms. Thermal energy is the cause and temperature is the effect. All living organisms need a particular temperature for their survival. In the kitchen, a container with a steel bottom is placed on the induction stove. Do you know why? All of us have a common man's understanding of thermal energy and temperature. But in this chapter, you shall learn about thermal energy and temperature in a scientific manner. We shall also discuss about how thermal energy is transferred and the effects of thermal energy. Temperature. Temperature is defined as the degree of hotness of a body. The temperature is higher for a hotter body than for a colder body. It is also be defined as the property which determines whether a body is in equilibrium or not with the surroundings, or average kinetic energy of the molecules. Further, temperature is the property which determines the direction of flow of heat. It is a scalar quantity. The SI unit of temperature is Kelvin, K. There are other commonly used units of temperature such as degree Celsius, degree C, and degree Fahrenheit, degree F. 1.1 Absolute Scale, Kelvin Scale, of Temperature. The temperature measured in relation to absolute zero, using the Kelvin scale, is known as absolute scale temperature. It is also known as the thermodynamic temperature. Each unit of the thermodynamic scale of temperature is defined as the fraction of 1/273.16 th part of the thermodynamic temperature of the triple point of water. A temperature difference of 1 degree Celsius is equal to that of 1 K. 0 Kelvin is the absolute scale of temperature of the body. The relation between the different types of scale of temperature. Celsius and Kelvin, K equals C plus 273. Fahrenheit and Kelvin, K equals F plus 460, asterisk, 5/9. 0 K equals minus 273 degrees Celsius. 3.1.2 Thermal Equilibrium. Two or more physical systems or bodies are said to be in thermal equilibrium if there is no net flow of thermal energy between the systems. Heat energy always flows from one body to the other due to a temperature difference between them. Thus, you can define thermal equilibrium in another way. If two bodies are said to be in thermal equilibrium, then they will be at the same temperature. What will happen if two bodies at different temperatures are brought in contact with one another? There will be a transfer of heat energy from the hot body to the cold body until a thermal equilibrium is established between them. This is depicted in Figure 3.1. When a cold body is placed in contact with a hot body, some thermal energy is transferred from the hot body to the cold body. As a result, there is some rise in the temperature of the cold body, and decrease in the temperature of the hot body. This process will continue until these two bodies attain the same temperature, energy. If you leave a cup of hot milk on a table for some time, what happens? The hotness of the milk decreases after some time. Similarly, if you keep a bottle of cold water on a table, the water becomes warmer after some time. What do you infer from these observations? In the case of hot milk, there is a flow of energy from the cup of milk to the environment. In the second case, the energy is transferred from the environment to the water bottle. This energy is termed as thermal energy. When a hot object is in contact with another cold object, a form of energy flows from the hot object to the cold object, which is known as thermal energy. Thus, thermal energy is a form of energy which is transferred between any two bodies due to the difference in their temperatures. Thermal energy is also known as heat energy, or simply heat. Heat energy is the agent which produces the sensation of warmth and makes bodies hot. The process in which heat energy flows from a body at a higher temperature to another object at lower temperature is known as heating. This process of transmission of heat may be done in any of the ways like conduction, convection, or radiation. Heat is a scalar quantity. The SI unit of heat energy absorbed or evolved is joule. J. During the process of transferring heat energy, the body at lower temperature is heated while the body at higher temperature is cooled. Thus, sometimes, this process of transfer of heat energy is termed as cooling. But, in most of the cases the term heating is used instead of cooling. When the thermal energy is transferred from one body to another, this results in the rise or lowering of the temperature of either of the bodies. 3.2.1 Characteristic features of heat energy transfer. 1. Heat always flows from a system at higher temperature to a system at lower temperature. 2. The mass of a system is not altered when it is heated or cooled. 3. For any exchange of heat, the heat gained by the cold system is equal to heat lost by the hot system. Heat gained equals heat lost. 3.2.2 Other units of heat energy. Though the SI unit of heat energy is joule, there are some other commonly used units. Calorie. 1 calorie is defined as the amount of heat energy required to rise the temperature of 1 gram of water through 1 degree Celsius. Kilocalorie. 1 kilocalorie is defined as the amount of heat energy required to rise the temperature of 1 kilogram of water through. Thank you for all. In our next video, we will post the 10th Standard Science, Unit 3, Thermal Physics about effect of heat energy.